So, record হচ্ছে না?
Yes, sir.
So, nanotechnology means you have prepared some substance or some material or some instrument with nanomaterial. So how you can prepare an instrument? Say, for example, you have prepared your laptop screen with quantum dot. Your laptop screen with quantum dot. Then it is a nanotechnology. Nanotechnology. What it is called? QLED or QD-LED. You will find nowadays the modern televisions, the screens are with your quantum dot LED. It will require much less energy than normal LED. Now, then the nanotechnology, under nanotechnology, we'll study two things: how a nanomaterial can be prepared, and two, that how a material, how an instrument can be prepared by a nanomaterial. But we chemists we deal with the preparation of nanomaterial. The engineers deals with the nanomaterial, the technology of nanomaterial. That means to make an instrument or make a substance or make a thing with nanomaterial. These are the job of engineers. But our job, the chemist job, is to prepare the nanomaterial. Wherever you will go, the chemist will prepare the nanomaterial. So we want to emphasize on the preparation of nanomaterial in the nanotechnology portion. Now, how do we build something so small? How can we prepare a very small substance which we do not see? We cannot even see a very small substance in nano level. How can you prepare like that? There are two methods. One is top down. Top down means we have a big substance, and from that we can prepare a small substance. We can hammer it. We can do something on that big substance, and then from that big substance we can prepare a small substance. That is a top-down process. And bottom-up process means from small substance, from very small substance to some bigger substances. Say, for example, a nanomaterial is a nanomaterial. Say, for example, one nanomaterial means 5 atoms. If you place 5 atoms side by side, that is one nanometer. So a nanomaterial with 1 nanometer of length consists of 5 atoms. A nanomaterial of 10 nanometer length consists of, say, 50 atoms. So if we arrange one by one 50 atoms together, then it is a nanomaterial. So we are preparing or we are building the nanomaterial. How? By arranging one atom with another atom with another atom. To what extent? Up to 50 atoms. We have to stop on that 50 atoms. It cannot be 100 atoms, it cannot be 200 atoms, it cannot be 300 atoms. So the main challenge is we are arranging one atom after one atom, but where to stop? This is the main challenge. We have to stop on that 50 atoms if we want to make a nanomaterial with 50 atom. So we have to stop on that 50 atom. We are not arranging the atoms by our hand, one atom and two atom, three atom. It is self-assembly. Atoms are attaching with each other uh, by self-assembly. They're self-assembled. So this self-assembly, we have to stop that self-assemblance in one point. And how to stop them? It is the actual challenge of nanomaterial of a bottom-up process. Now, among the top-down and bottom-up process, the bottom-up process is very popular because in the bottom-up process, we do not have any wastage of material. We arrange one by one atom, and when 50 atoms are gathered together, then we will stop here. That is a bottom-up process. But if I break this type of material to a 50 atom nanomaterial, then other materials will actually this is a other material loss. This is a loss of material. So so this is not a top-down method is not very much popular, but in some cases it is used. In some cases, it is used where the bottom-up process cannot be used. In some cases, top-down method is used, but bottom-up method is very much popular. Now, the top-down fabrication, actually, it is used in the circuits. In the circuit industry, you see this is a motherboard. In the circuit industry, the top-down method is used, and it is known as lithography. Lithography, there are different types of lithography. Photolithography is very popular. So we will see it later. We'll see it later. We'll see it later details. The top-down fabrication mainly used here in circuit industry, and and the bottom-up process is used mainly in all industries for growth of the nanoair, or for to make carbon nanotube, and many nanoparticles. You can use the bottom-up process. How? By arranging one atom with another atom with another atom, and at one point we have to actually close the assembly. This is the main challenge of bottom-up process. Now we will see how it is done. Uh, there are many ways to make a bottom-up fabrication. Now we'll see it. The first method, which is very much popular, it is known as sol gel method. Sol gel method of making a nanoparticle. It is very popular method for the chemists and for other physics, for other discipline researchers also. The sol gel method. By this sol gel method, we can prepare all type of nanomaterials. That means a thin film, solid nanomaterials, all type of nanomaterial. What is this sol gel method? The sol gel process is very long known since the late 1800. What does it mean? The process is known, it is a very old process, but the process of making nanomaterial is the new process, because nanomaterial, it is actually discovered in 1985 or 1991, whatever you say, after that. But the sol gel preparation of sol and gel, it is a very old thing. Prepare how to prepare a sol or how to prepare a gel. So in 1970, when glasses were produced without high temperature melting point, in 1970, a glass is made with a temperature of above 1500 degrees centigrade. But in this salt gel process, glass can be made with a very low temperature. This is different thing, but this is actually a very old process. So what is salt gel process? Salt gel process is a chemical solution process used to make ceramic and glass materials in the form of thin films, fibers, or powders. By salt gel method, you can make a thin film. I have told you what is thin film. It is a two-dimensional nanomaterial, length and breadth. It is not nano, but the width is nano. It is a 2D nanomaterial. We call it quantum well. So what is a sol? A sol is a colloidal. That is, the dispersed phase is so small that gravitational forces do not exist. In a colloid, you have studied the colloid. In a colloid, it is a very fine particle, very small and fine particle dispersed in a liquid. Fine particle dispersed. There are different types of colloids, but we are telling about that as sol. There is a dispersed phase which is so small that gravitational forces do not exist. In Tyndall effect, you have seen that when sunlight falls in any place, you will see some small particles are floating there. That is Tyndall effect. So this is sol, where sol so fine the particle is, that the sol is so fine, which is dispersed, that it cannot sediment it. It cannot be sedimented. The particle is so fine that it will not be sedimented. So this is called sol, and only van der Waals forces and surface charges are present in that sol per dispersed phase. So a sol is a colloidal or molecular suspension of solid particles of ions in a solvent. So very small particles that are dispersed in a solvent. And what is a gel? Gel is a semi-rigid mass that forms when solvent from the salt begins to evaporate. So you have a colloidal solution of salt, and you have evaporated the solvent. Or what can happen? The salts are condensed, interconnected with each other. If salts are interconnected with each other by any means, by condensation reaction or by something, if the salts are interconnected with each other, then gel forms. We have a very good example of jelly in our everyday life. It is a gel where the salts are interconnected with one another, and it forms jelly, and it forms a gel. But no, your no solvent comes out. This is also a gel. So, what is a sol and what is a gel? Sol is the small particle dispersed in a liquid, and when these small particles are interconnected with each other, it forms a gel. That is what is sol and gel. Now, what is the principle of sol-gel method? Sol-gel method involves the formation of salts in a liquid and then connecting the salt particles to form a network. If salt particles are connected to form a network, then it forms a gel. And by drying that liquid, if you dry that now, then you will get the powders or thin films, etc. So, how a sol or gel can be found? Sol can be found by hydrolysis and condensation and polymerization of monomers to form particles and agglomeration of particles. After the formation of sol, the formation of the network, that means gel, is formed. So we will see how it is formed, but again we will see the process again. Here in this slide, you see here a sol gel process is a wet chemical technique that uses either a chemical solution, the sol is the short form of solution, or colloidal particle, sol for nanoscale particle, to produce an integrated network gel. Now, how can we prepare the sol? That is the first question. How can we prepare the sol? We prepare the sol in situ, there in the beaker where gel is formed. To form gel, first we have to prepare the sol. We will prepare the sol by reacting, say for example, A with B. If A and B reacts with each other, then a compound forms, which is a sol. That means a very small particle which will not sediment it. That is sol, which will not precipitate it. That is sol. Or you can use sol. You have prepared sol outside somewhere, a nanoscale particle, and then you can give it to a solution and you can stir it to form a gel. Now, what is gel? We have prepared sol, say for example, in a beaker, we have placed A and B. A product is formed, C. C is a sol. That means C is a compound with a diameter, very small diameter, like a sol, a nanoscale particle, and after the formation of that nanoscale particle, it becomes condensed. That means attached with one another to form a structure. Then it becomes a gel that is called an integrated network. So we can prepare sol. We can use sol by two ways: by preparing sol in situ, or by preparing sol outside and then using it to form a gel. Metal alkoxides and metal chlorides are typical precursors. That means the starting material. Precursors mean starting material. The starting materials are mainly metal alkoxides or metal chlorides. These metal alkoxides and metal chlorides, in presence of suitable catalyst, undergoes hydrolysis in the solution. If you give metal alkoxide or metal chlorides in a solution or in a solvent, then it will hydrolyze in the in presence of a catalyst to form a colloid. That means sol is dispersed in the solvent. Then to form a colloid, a system composed of nanoparticles dispersed in solute. That means colloid. What is colloid? A system that composed of nanoparticles dispersed in solvent. Dissolve evolves then towards the formation of an inorganic continuous network containing a liquid phase gel. This sol becomes attached with each other to form a network which is called gel. Formation of a metal oxides involve connecting the metal centers with oxo or hydroxo bridges, therefore generating a metal oxo or metal hydroxo polymers in solution. In solution, what happens? We have used metal alkoxides or metal chlorides. This metal alkoxides or metal chlorides forms this type of polymerization, which forms the gel. After drying the gel, the liquid is evaporated from the solution, and when if you heat the gel, you will find the your nanomaterial. You will find the nanomaterial. If you heat the gel, then you will find the nanomaterial. Now, if I show you the figure, then it will be more easier for you. You see, first, the solution of precursor. What is the solution of precursor? Well, solution of precursor means solution of metal alkoxide or metal chlorides. Then here the metal alkoxide and metal chlorides formed when they are condensed. We'll see the reaction later. We'll see the reaction later. When they are condensed, then they forms salt. They form salt. This salt, you see, this is the gelation, formation of gel. This is the formation of gel. You see, there is a three-dimensional network. It is a three-dimensional network. This is the gel. This is salt and this is gel. Same thing. This salt is interconnected with each other to form a three-dimensional network to form a gel. Now you can make nanoparticle by various way. You can make nanomaterial by various way. From the salt, you can make nanomaterial. How? You can dip a substrate here. You know what is substrate? A substance where nanomaterial can be deposited, that is called substrate. Say, for example, a glass substrate, a silicon wafer substrate where nanomaterial can dissolve, can deposit it. Say, for example, this is a substrate. So you can dip a substrate here. You can dip a substrate here to form a thin film, or you can draw fiber from here, or you can dry this salt without formation of gel. You can dry this salt to form a powder. That is also a nanomaterial. Now, after the formation, if you don't want to these steps, if you don't want these steps, then you allow the salt to form gel. How do you allow the salt to form gel? Just keep it for some time. That is called aging of the material of the solution. That is called aging of the solution. Okay. Okay, now you don't require these steps, you don't want to do these steps, then you allow to stand this salt for some time, then it will make a gel. What is a gel? A three-dimensional network of salt. Now in this three-dimensional network, this gel, you can dry this gel. You can dry this gel by two ways. One is called some supercritical drying, where you see here the liquid is evaporated, but the three-dimensional network of the salt remains. You see here the network of the salt remains. That is called supercritical drying, where the three-dimensional network of salt remains. That is called three-dimensional network, that is called aerogel. This type of substance where three-dimensional network is retained, and there are, you see there are vacant spaces here as because of three-dimensional network. So this is known as aerogel. And there are another type of drying where this three-dimensional network collapses. You have dried the solvent. Actually, it is called calcination. You have dried the solvent. You have calcined the solvent, and then this three-dimensional network collapses here. You see, there is no three-dimensional network like here. This is called zero gel, where the three-dimensional network collapse. That is called zero gel. And if you grind this zero gel, then you will find the powder of the salt. This is also nanoparticle. Or you can sinter it. Sintering means pressing it. You can pressing it for a definite shape. So you can sinter it to form a dense ceramic. We can sinter glass also. You have used sintered glass crucible in your laboratory to filter any precipitate. So so you can make different types of nanoparticles with sol gel method. That is aerosol. Aerosol, it is a porous substance. It is a porous substance with many pores here. Sorry, it is aerogel with porous substance with many pores here. And you can sinter this also to form a sinter substance, or you can sinter aerogel to form a sinter substance. You can grind the aerogel to form a powder nanomaterial. You can find fiber, nanofiber. You can coat any substrate from the solid itself. That is the simple way of sol gel technique. This is very simple of sol gel technique. So what you have to do, you have to condense the first. You have to hydrolysis. You have to do the hydrolysis of the metal alkoxide or your metal chloride solution. Then you have to condense it. This condensation is of two types. One is normal condensation, and another one is polymerization. Another one is through polymerization. We'll see it later in details. Another one is polymerization. Then sol is formed. After the formation of the sol, gel is formed. If you want gel, then you keep it for some time, then gel will form with a three-dimensional network, and you have to dry the gel. The drying process is of two types. One is calcination, another one is supercritical drying. In supercritical drying, you will retain the three-dimensional structure of the sol, which is called aerogel, which is porous substance, which have pores there. And if you calcine it, that means heat it to dry, then you will find gerogel, and this gerogel you can grind it to form a powder nanomaterial, powder nanoparticle, and you can sinter it to form a particular structure. Now, after hydrolysis and polymerization in the salt substance, you can coat coat a film. You can coat a film at one end by spin coating, or you can coat film in both ends. If you dip this substrate to the salt solution, then you will find coating in both the ends. But if you spin coating, that means if you spray this salt solution to this substrate, then it is called it will move, and one side is coated, a thin film is produced, then it is known as spin coating. In You see a zero gel film in in one side, and here you will find the aerogel film in both sides. It is how you require. It is on your requirement. Now, the steps of salt gel process. There are 4 steps of salt gel process. First one is hydrolysis. I have told you. First one is hydrolysis. The precursor is metal alkoxide or metal chloride. So first you have to hydrolyze the solution, hydrolyze the metal alkoxide or hydrolyze the precursor, then condensation, and then aging. Aging means keeping it, and then drying, drying the drying the substance. So if we see a salt gel preparation reaction, preparation of silica gel. Have you heard about silica gel? I think everybody of you heard about silica gel. Silica gels are some blue type of substance used generally used as desiccant. Desiccant, under the desiccator, the absorbs the water from the desiccator. So this is this is one type of alkoxide, silicon, or R means let's CS3, OCS3, that is methoxy. First one is hydrolysis. First step is hydrolysis. You see here, this is hydrolysis. Hydrolysis, the OH is coming and ROH is going. This hydrolyzed, this hydrolyzed substance, this is condensation. You see here, this is condensation. Water molecule is going out, and this is the condensation product. And the condensation may be in different way. One alkoxide and one alcohol can be condensed, or 2 alcohol can be condensed. If one alkoxide and all alcohol condensed, then an alcohol is going out, but the same product is you will find the same product. Now, this is the salt. This product is the salt. Now we find the salt here, and one of these is linked with this molecule. These are linked with this molecule by a 3-dimensional way. Then it is a gel. So what is the reaction? First is the hydrolysis, and next to a step is condensation. In one step, water is removed, and the second step, one alcohol is removed, but the but the main product is same. But the main product is same. So this is the salt. This is the salt molecule. This is the salt molecule, and this salt molecule, this salt molecule will make come. First one is hydrolysis, and then condensation, and then aging. That means that means salt is produced. That is, I have shown you that these are the salts, these are the salts, these are the salts. The two silicon molecules, the molecule with two silicon atom, it is the salt. And after this, aging means keeping that in situ, you'll get the gel. It is as simple as that. You'll get the gel. So this is aging. You will get the gel, and you will dry the gel then by supercritical drying or calcination. Now, next day, we'll see the details of salt formation, condensation, and everything. We'll see in details. Now, this is the simple way of sol gel process. Okay, it is now about 9. So you can stop here today.